All right, so this will be good. We're going to get a lot of review today and also practice some trigonometry stuff and connect some of the new things we've been learning to some of the old things that you already knew. So, important definitions in this first part. They tell us that an angle's in standard position and that there's a point on the terminal arm. So what does this mean? Well, if I draw my four quadrants, angles in standard position always start here from your positive x-axis. And if I label the point -2, -4, right here, that point is on the terminal arm. Now, a terminal arm is where an angle ends. So this is the angle in standard position. This is the angle theta. So first of all, just reading the question, knowing what standard position is, knowing that the terminal arm is where an angle ends, that sets up this picture. And trigonometry is about drawing triangles, and so the picture is very important. So now, it says in A, based on this information, to determine the primary trig ratios. So in A, we want to find out what's sine of theta, what's cos of theta, and what's tan of theta. And from grade 10, you know that if you have a right-angled triangle, SOHCAHTOA tells you sine is the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tan is the opposite over the adjacent. But we need a triangle. And this is where the grade 11 math introduces you a couple of new things. Okay? The new things that it introduced to you was that the angle to the nearest x-axis, this right here, that is your reference angle. And reference angles are extremely important because if you do sine, cos, and tan of the reference angle, it's the same as sine, cos, and tan of the regular angle, but sometimes it's positive and sometimes it's negative. And the other important new thing that we learned this year was that you can tell where things are positive and negative with the cast rule. The cast rule tells us where things are positive. So the C in quadrant 4 tells us only cosine is positive in quadrant 4. The T in quadrant 3, that's actually what's going to come into effect here. Can you see that our angle is in quadrant 3? So we're going to, in the cast rule, say, I already know from the cast rule that my sine value and cos values are going to be negative, and my tan value is going to be positive. So how does the reference angle come into play? Well, the reference angle will always be an angle, and I'll draw it in purple. If we go back to the nearest x-axis, we make this right-angled triangle. And on that right-angled triangle, because you know the point on the terminal arm, you know some lengths. You went 2 in this direction, you went down 4 in this direction. And that's enough for us also. Because it's a right-angled triangle, we're allowed to use a squared plus b squared equals c squared. When you square root, you're supposed to remember the plus or minus, but because it is a length, it'll be positive, and the square root of 20, we can use our radicals unit and simplify that to 2 root 5. So I can label that on my triangle as well. I know this side is 2 root 5. So really important that we draw that triangle back to the nearest x-axis to use our reference angle. And really important to know that reference angles are so important because if sine of my reference angle is opposite over hypotenuse, sine of my actual angle will also have that same ratio, and we would then use our cast rule to determine this is negative. Does the answer at the bottom have it look like this? They've reduced it, okay, and they left, so do you see that the 4 over 2 reduces? They left the square root on the bottom in the answer key because it might have been that some teachers decided to teach this before the radicals unit. But since you've learned the radicals unit already, if you left your answer like this, you would lose a half a mark for not simplifying. Not only do we have to simplify that 4 and the 2, but simplified also means we don't have square roots in the bottom of our fraction. So how do I get rid of that square root on the bottom? I would multiply top and bottom by the square root of 5. And then that would give me, I'm trying to think how many steps should I do it. Should I just take it? I'm going to take it extra slow. Some people might already simplify the 4 and the 2. I'm going to do that at the end. I'm going to have negative 4 root 5 over, and root 5 times root 5 is going to be 5, times the 2 is 10, and then the 4 over 10 reduces to negative 2 root 5 over 5. So we have the new ideas of the reference angle and the cast rule, but then a whole bunch of other math that we've done in the past we have to use. We have to know SOHCAHTOA. We had to know a squared plus b squared equals c squared. We had to know how to simplify fractions and also simplify with radicals. Okay, so now we're going to review that for cos theta and tan theta. I still have my triangle. Cos of theta is the adjacent over the hypotenuse. So I can write that as adjacent side is 2, hypotenuse is 2 root 5. And according to the cast rule, since I'm in quadrant 3, only tangent is positive, so I have to make sure I add a negative with cos of theta. Once again, multiply top and bottom by root 5. I'm going to also simplify these down to 1 right away. So I'm going to get negative root 5, and root 5 times 5 is 5 as my cos ratio. And finally, my tan ratio is opposite over adjacent, which would be 4 over 2. Tan is positive in quadrant 3. And of course, this simplifies to be 2. So you found all of your trig ratios. And now that we've found all of those, in part B, it says, now we can find theta. Okay? And the interesting thing is when you're doing solving for theta, going back to grade 10, you know how to solve for theta in triangles. So we have to go and look at our triangle, and in our triangle, we don't have theta in our triangle. In our triangle, we only have the reference angle. So what we want to do to find theta is we first want to find our reference angle. And our reference angle has the exact same ratios as all of these. So if I was choosing one, I would probably, right? I go to my triangle, my reference angle is here. I would probably choose 10 just because it doesn't use a square root. The other ones are going to work fine. You could use your calculator to do them as well. Okay? And I know that tan was positive in quadrant 3, but this is going to be very important, is that when you're solving for a reference angle, you're solving for an actual triangle, and an actual triangle has all positive lengths. So no matter what you're doing, even if you did sine or cosine, when you put your reference angle in there, it would always be positive.
Would you have to use the 4/2, or would you be able to use a 2/1 and get the same?
You would get the same thing, because remember, with triangles, it doesn't matter how big or how small, the angles would stay the same. So I could reduce this. I just used 4/2 because I looked back, I said, I'm using my actual triangle. The lengths were 4/2. When you go to solve, you can just plug in 2, because 4/2 reduces to 2. So I go to my calculator. To find the angle, I do tan inverse up to, make sure my calculator's in degrees. I'm just going to want, it says round to the nearest degree. So I go second, tan inverse of 2, and I get 63 degrees, rounded to the nearest degree. Again, if I hadn't read that before, I would probably, even here, I'd put 3 decimal places and just round my final answer. So now we just found the green angle. I'm going to put a green box around this, because we just solved for the green angle, which is our reference angle. And now looking at your picture, you have to figure out how would you find the blue angle theta. And does it make sense? And maybe you even want to write it in here. Based on this picture, does it make sense that I could go 180 degrees, which go halfway around, and then add my reference angle to that? There are some students who memorize that in quadrant 3, your angle is always 180 plus the reference angle. I don't think you need to memorize that. Save your brain space memory for other things. Doesn't it just make sense when you draw the picture that it's going to be 180 plus the reference angle? If it makes sense to you, you just save yourself a whole bunch of time studying, because you don't need to memorize that. You just have to tell yourself, it made sense to me, so that means you can figure it out. And the more things you put into that category for yourself of, it makes sense to me, I don't need to memorize it, then even if you forget trig for like 3 weeks, when you go back to it, you'll be like, oh yeah, that made sense to me, and you'll be able to figure it out again. If you just memorize something and you forget it, your brain's going to be like, yeah, you forgot it. There's no hope anymore. So the more things that make sense, I think it makes sense to say that's 180 plus our reference angle. So now I can say that theta is going to be 180 plus the 63 and get 243 degrees. Super important that we understand how powerful reference angles are, because trigonometry moving forward always comes back to this idea of the reference angle. You can circle questions for this one, 6, 10, and 11.